I read this somewhere in some documentation somewhere. Server components are not sent to the browser, so they cannot use interactive APIs like useState. Actually, before I go on, does anyone here, who's here has heard of server components? Right, okay, a lot of people. So they're a new sort of feature by the React team to do static content and more than that. But yeah, server components, they are not sent to the browser, so they cannot use interactive APIs like useState. And as a Rails developer who knows React, but doesn't use anything like Next.js, hearing this was a bit of a confusing moment, because for me, what is React without useState? What are you guys doing? You're just sort of JSX components rendering on the server. I didn't really get it. And so this talk is a bit about how I read the docs, actually programmed up some sort of little demos and stuff, and learned to understand what all the front-end developers are actually doing. Because from the outside, so this is a picture of the Tower of Babel. And so from the outside, seeing everything that front-end developers are doing, it sort of feels like this increasingly large construction of complexity, and there's very much a sense of like, why on earth are people doing this? Yeah. So this is a nice little graph that I made. So on the left, we have user experience. On the bottom, we have static UIs and dynamic UIs. And then this is sort of my perception of where React and Rails fit on this, right? So on the left, static UIs. Rails is really good at static UIs, right? Content, forms, Rails is unbelievable at this. So much so that I've heard Rails described as just a giant form library, which is pretty accurate. And then on the other end, we have React, which is not as good at static UIs, but really, really good at doing dynamic UIs. Yeah. So I'm going to go through some examples of both React and Rails trying to solve both of these problems and sort of the contortions that they go through to solve the problems that they are not so good at least in their sort of vanilla iterations. So the first thing we're going to do is we're going to look at some content. And so I made a very simple demo. It's just books and reviews. And so it's just content. There's no interactivity. It's all static. In Rails, making this was trivial. It took me like 10 minutes. And so most of you, many of you probably don't know how Rails works. So I'm actually just going to go through what it takes to make this demo. So the first thing is, in Rails, you have this idea of routes, and you have this big routing file. Is this big enough? Yeah? A little bit bigger? Let's go a little bit bigger. Yeah. I think that's as big as it goes. Okay, so these are for all the different demos. The one at the bottom is the one we're looking at now. This one. So it's just URL path that maps to something called a controller. In Rails, controllers are sort of the brains of the operation. So if we go here, that route maps to this controller. Controllers basically look at the incoming request, they do business logic, talk to databases, caches, whatever, and they assemble the response that goes out. And so for this example, the controller is you just make a variable, you pull this book model right here. This is how Rails talks to the database. And so we're just loading in books from our database, and then we go to, oh, what's going on? We go to a view, Rails index, this. And this is just HTML template. We have access to our books right here, and we just iterate over them, and we render content. And that's the end of it. It's just a route, a controller that talks to the database, and then it renders the page. And it does this all on the initial request. So there's no, if you go look at the network panel, yep, we just hit this. Oh, what do I gotta do? All. So it's loading a bunch of JavaScript, yada yada, but this is just rendered HTML, and just gets loaded on the page. It's nice, it's beautiful, it's fast. everybody loves it. Rails is really good at this, and you can do this kind of stuff really quickly in Rails. So what I'm going to do next is a couple of examples of how one might do this in React. So the first one is sort of vanilla React. No Next.js, Gatsby, Remix, anything like that. No server components. So we're going to look at it, and the first thing we see is a spinner. Everybody loves spinners, right? Have you guys seen spinners? Yeah. Okay. My favorite spinners are the ones where they, it's not actually a spinner. They render like a, yes. Yeah, the little shadow of the content. It looks like what you're going to get. It's not what you're getting. It looks a little better. Yeah, okay. So this is just vanilla React. If we go back to the network panel and we re-render it one more time, so we get everything in here. The actual initial HTML that gets sent over, I'm going to make this bigger. Can I make this bigger? Let's try this. There's nothing in here, right? Well, where is it? Just JavaScript, and then it just animates the spinner, and it doesn't do anything. And then, oh, this is huge. Let me see. Yeah, okay, so then for the different components, they're each going to the database and they're fetching the data they need to render. And this is why you need to have the spinners, because you're making these secondary requests to the server. And then React renders the component once it actually gets the data. So if we actually go look, React content, if we look here, right, so this is just the React component for that page. Down at the bottom, we have the JSX that just conditionally renders a loading spinner right here. Oh, maybe not, here. And then otherwise renders the books once they're actually loaded, and then we're just using useEffect. Once the component mounts, we go and we fetch data from the server, and it does the same thing for the reviews. And so this is vanilla React, and we have the spinners. So if we go back to our little graph, this is over here on the left, static UIs for React. Not so great with just vanilla React. And so what I'm going to go through next is ways that React and React meta frameworks try and get a, go ahead.
So when you say vanilla React, you mean a SPA React? Everything's client-side? Or
Yes, so everything is client-side,
Gotcha.
and just with React and no additional libraries. But now, who sort of gets server-side props? Everybody knows what it is? Yeah, okay. So this is Next.js's older way of solving this problem. And so if I click here, boom, the page just loads, there's no spinners, everything's beautiful. If we go look again in the network panel, we see, oh, I gotta make this bigger. Yeah, here we go. You can see everything comes pre-rendered. The whole page is rendered on the server, and so it loads on the page immediately. And this is really good for two reasons. One, the user experience is better, you don't have spinners, and then two, for SEO spiders from Google. They see the content immediately, and they can, I don't know, do their magic on it, read it. If they see the spinners, I think they just leave. They don't wait. So your page to them is sort of just invisible, empty, which is really bad for static content, anything like e-commerce or content sites where you really want Google to like what you're putting on the page. And so this is implemented. Is it this one? Yeah. Okay, so this is a very similar component. We have featured books. It's the same JSX, but if you see there's no useEffect, it does this get server-side props. And so this, on the initial request, it will execute this function. It'll go to the little database I built. It'll get all the props. It will render the page, send all the HTML over, and everything is nice. One thing to note, and I'm going to show you another example that does nearly the same thing, is that when we look here, Is it this? Yeah, okay. So when you use get server-side props, it actually sends the props in addition to the pre-rendered HTML, and it does that to do hydration. Who knows what hydration is? Right? Most people? Okay. So when you do this kind of rendering, it sends the HTML over immediately, it renders immediately, but none of it's interactive. And so nothing on this page, well, you can't see it anymore, but nothing on this page is actually interactive. But if you were to have some interactive elements, React will use the props that are sent down, or Next.js will use the props that are sent down, and it will use those to turn this sort of bare HTML into interactive React code. It'll add all the event listeners for all your clicks and all your submits and everything, and it uses those props to do everything. So now we're going to see sort of, so this is kind of some context. This is kind of the, I guess now, the older way of doing things. So you have these meta frameworks that were born on top of React to solve this problem. The big ones are Next.js, Gatsby, and Remix. And to my understanding, they all kind of came up with different ways of solving this problem. And it's only recently that the React team themselves have come up with their own way, which will seemingly become the way things work moving forward, and that's called server components, and that's what inspired this talk. So we're going to do the same example. This is built with the new server components. It looks identical, it loads instantly, it's solving the same problem. The code is a little bit different. So this one was the old one where we had get server-side props. And let's go React. Here we go. This one? Yes. Okay, so again, we have a React component. We have the same JSX, but this one's different. There's no get server-side props outside of the component. This is using React server components. And this is the components that only render on the server, and they don't have any use state in them. This is a server component, and one thing to note, the important part to note is that the component itself is now rendering with async, and you have at the top of the component your various awaits going to the database. In vanilla React, you can't do this. It doesn't work. But with React server components, this is how it does. This is how it solves that same problem. So it's pretty much the same code. It's just the component itself is async, and then you write your awaits within the component. One thing to note here is that React server components do a couple of different things all at once. So nothing on this example is actually interactive. If there was something that was interactive, you would have to have a nested component, and then at the top of the file, I think, what is it? It's like use client. Does anybody know? Yeah, is that, okay, so that's right. So when you use server components, when you do want to have interactivity on the page, you have nested client components that have all your regular use effect, use state. And so you define these boundaries between content that is rendered on the server in the initial page request, and then other components that are interactive, and they can't do this style of like async, get stuff from the database. They just work like regular React components. Okay. So that is sort of the steps that React has to take to be able to render these types of pages and this type of content quickly without spinners and in a way that they can be sort of properly SEO'd. So if we go, where'd it go?
So with the server component, it's like it's the first 8 delayed slightly compared to a stack, like to a spa.
I'm gonna be honest, I don't know. I know that the get server-side props versus server components have different effects on the first content paint and when things get initially loaded, and I can't speak with confidence on which ones happen faster or later. I know that depending on how you do it, and then for each of them you can do them in slightly different ways, it will have effects on that like initial page render, especially with like hydration and stuff like that. and whether or not that happens. But the details of it,
Yeah, I'm not trying to be like, this is wrong. I'm just
oh,
trying to reason it out.
no. So I actually read, when I was kind of setting all this stuff up, I read a really good blog post about server components that had these nice little diagrams of all of those things and the consequences of doing them in different ways. I actually wish I had a link. I might be able to find it before the end of this, because it was really good. But so this, nice little funny meme. So this is Rails looking at all the things that React has to do static content. And so as a primarily a Rails developer, but I use React a bunch, this is sort of like the Tower of Babel that all the front-end developers are sort of assembling to solve what, to Rails developers, is like a trivial problem. And so what I'm going to do now is do it in the other direction, right? So we're going to have a little like dynamic interface example, and I'm going to start with React and then show you the sort of ridiculous things that Rails is doing now to try and meet the sort of same needs. So if I go back here, yeah, React tab. So this is made in React. I just made some generic interface. You have little tabs, and you have a form, right? You can fill out the form, and it's nice and beautiful. I'm not even going to show you the code for it because it's sort of trivial React code. You just have state for which tab you're in, and that's kind of it. You click on the links and it changes the state, and React re-renders things the way you would expect it to. In Rails, if you do this with vanilla Rails, the experience is not so great. So first off, right, I click through the tabs. One thing to notice immediately is that every time I click on one of these tabs, it's a whole separate page with a whole separate re-render. It re-renders the whole page, and it re-executes all the JavaScript. In this example, there's no JavaScript, so that kind of doesn't matter, but if you have a real application where you, even in a Rails application, you still have a bunch of JavaScript, it's kind of slow, and you'll get the, like the whole page blink where it'll turn white and it just wipes everything. And then, more importantly, whenever I do anything on this page, it wipes out all the state that I have on the page, right? So if I fill in this form, but I don't fill it all the way in, and I go, oh, I want to look at my friends, it wipes the form because it's re-rendering the entire page. And then the same thing the other way around. If I'm in this message and I want to send a message, but oh, I want to submit this form as well, when I submit this form, it's going to do the same thing. It re-renders the whole page, it wipes out all the state that is on the page. And so this is vanilla Rails, and this, for any kind of like the smallest bit of interactivity, the experience gets really bad really quickly. And so traditionally, you just add a bunch of JavaScript to the page, and you can either use vanilla JavaScript or jQuery. At our company, we just throw React on the page to do stuff like this. But in the last couple of years, Rails has been developing a library called Turbo. Oh, actually, I think yeah, okay. We'll go back to it. Let me go back to my examples. So they've been developing a library called Turbo. What is going on here? Hello? Yeah, okay. Who has heard of HTML over the wire? Yeah, a couple of people. So the idea of HTML over the wire is rather than sort of storing state on the client in JavaScript, you just try and store your state on the server, and rather than doing these full page refreshes, you just re-render sections of the page and swap them in and out. So this page, I've implemented this HTML over the wire library that Rails has called Turbo. And let's see if I can actually find, sorry, this is really zoomed in. Actually, let's just look at it first. Okay, so let's try and do sort of the same problem we had before, right? So if I fill this in, but I don't want to send this, I want to come over here and I want to submit this form first. With Turbo, it doesn't wipe out the state of what's in the tabs. It doesn't change what tab you're on, and it doesn't change what's in the, like whatever state you have in any forms there. which is really nice. And the way it does this is that rather than re-rendering the whole page, you just tell Rails, when I submit this form, send me back the HTML for only this form, and just swap it on the page. Don't re-render the whole page. Don't re-execute the JavaScript. Just send me back a snippet and swap it in and out. And it's the same for the tabs too. It works the other way around. Like if I have this like this, and then I click through these, it doesn't wipe out the state over here. And so if we actually go look, again, let's clear this. Where'd the clear button go? Here we go. Let's submit this. We're going to submit this form. We're going to see submit. I just get this, and it sends me back. Can I make this? How do I make this bigger? Here. It sends me back just the HTML for the form. And it uses these HTML types called, oh, no, that's not the right one. That's telling it what to do. Where's the turbo? Oh, right. It uses these things called turbo. Is that it? What's going on? This is weird. Oh, here it is. It uses these things called turbo frames, which you put into the HTML, which tells the turbo library what part of the DOM I'm swapping in and out. And so this works really well for interfaces that are a little bit more dynamic than just nothing, than just static content. But once you start to get to really dynamic stuff, it kind of starts to fall apart. So like the sort of underlying issue is that no matter what you're doing with this, you're still not tracking state on the client. You're just sending over HTML snippets and swapping them in and out. And so you're sort of flying by wire. And if you start to do things that are like significantly complex, it's really easy to just lose track of what's going on and what you're doing and what's going to happen on the page. Because you don't actually have any state on the client that's keeping track of things. Oh, and this example is also a bit of a lie. If I click on these, it's really nice and really fast. But all of this is happening over the network, right? So it's all happening in my laptop right now. So all these things get re-rendered and they come back really quickly. If I go, where is it? I just changed it here, right? Let's do this. And I gotta restart my server, which is this one. All right. So I had a little thing to simulate network latency. And so now when I click on friends, there's a little bit of a delay. And if I click on profile, there's a little bit of a delay. And this is sort of an insurmountable problem with any sort of HTML over the wire. We're gonna keep track of state on the server. No matter what you do, you have network latency, and so any of these updates do come with that delay. And there's, Rails kind of just deals with it. You just have the network delay. There are other frameworks that do a lot that are sort of the same HTML over the wire type of deal, and they do a lot to minimize that delay, but kind of no matter what you do, it's there, and it kind of makes the UI just a little bit janky. And of course, you don't see this in React because it's all happening on the client. Yeah, so I wonder, is there any code in here that's worth looking at? Kind of not really. So that's sort of the idea. I skipped over, I'm going to do this. So this is the same meme, right? So this is React looking at all the HTML, all the Rails people and their ridiculous libraries of Turbo and Stimulus and HTML over the wire. This is nonsense. What are you people doing? Just put state on the client, and then everything works nice and easy. Right, so vanilla Rails is bad for dynamic UIs. Libraries like Turbo are sort of born to address this kind of issue, and they don't go all the way there. Yeah, and so kind of similarly with React trying to do static content, you see this sort of significant addition of complexity to solve problems that it wasn't originally designed for. And so similarly for React, yeah, so same thing on the other way. Vanilla React is just bad for static content. Meta frameworks like Next.js, Gatsby, and Remix are born to address these issues. React, they developed their server components to kind of do it all in one way. And then it's the same thing. So significant added complexity. Yeah?
What if we have the same problem with this for server components?
Say that one more time.
For server components,
Yeah.
Would we have the same problem with logging Ruby?
In which specific problem?
I mean, if we need to change our content on server and send us rendered page, and
So-
we get bugs on our internet.
So on the initial page load, yes. I mean, you have to do the initial web request. With the server components, there's the interactivity would all be done via client components, which are the same, which work the same way as just regular React, and they have use state and they do all the dynamic stuff that way.
Basically, we can't do the app only by server components. We need this use client components.
Yeah, so.
This kind of situation.
So if you have a page that has both static content that you want to load immediately and dynamic sort of UI stuff, you have to have both types of components. So you have server components to do all the static stuff and to do initial rendering and go to the database in that first request rather than having to do use effect to go get it. And then you still have access to regular client components that have use state and use effect and do everything dynamically on the client. So you actually do really kind of get the best of both worlds. And between the two of them, Next.js or server components and React, it's pretty nice versus Turbo, which again, once you get significantly complex, it kind of falls apart. Okay, so yeah, so this is Rails developers using Turbo and React developers using server components. They're both in sort of the same position where they're trying to, if I go here, yeah. I'm just going to walk over here. Right, so with Rails, you have, it's really good out of the box with static UIs. With dynamic UIs, it kind of sucks. And so you have things like Turbo to try and push this line up and to make it better with dynamic UIs. And then it's the same way with React, with server components and get server-side props, trying to push this static UI, static content stuff up and make the experience better. And so what's happening is sort of whatever framework you have, everybody's trying to solve both problems at once. And yet, the thing is that every website and every application, they generally have both. You have static content and dynamic UIs, and whether it's 90% on one end, you still want that 10% to work really well, regardless of which direction you're in. And it is, as somebody who does Rails and React, and having seen them sort of get stitched together, kind of like a little Frankenstein, it's really nice to just use one tool for everything. Because I know for us, like, every part of the UI that we have in Rails, like every tooltip, every accordion, every drop-down, if you're using both, you have to re-implement it in React, and that's a huge pain to do. Yeah.
Can you say that again, about re-implementing React?
Say that one more time.
Say that again, last thing you said about re-implementing in React.
Oh, yeah, so in Rails, like if you build a page and you use just vanilla JavaScript or jQuery or whatever, and you build it up and it starts to get more and more complex, or you use Turbo, same thing. Once you sort of go across that line of where like, this is really hard to maintain and it's really hard to build, and if you do want to swap over to React, which our company has done a couple of times, you have to go rebuild stuff, which is just a huge pain and takes a lot of time.
You were saying if you do Rails, you have to code it like a Rails way or a Ruby way and a React way.
Oh, well, sort of with like just individual pieces of the UI. Like if you have your whole website and you have parts of it are in Rails, all like the little pieces of the UI, you have to implement them in Rails, or just in like vanilla JavaScript for like small little pieces of it. But then if you do have a page that's in React and you want it to look and work the same, then you have to go implement all those same like utility UI elements in both frameworks, which does suck. Okay, time check. Where are we?
Like 10 minutes.
10 minutes? Okay. So I didn't have time to actually make an example for this, but I did want to talk through it because this is something that Rails is really bad at. So we went through like static content, we went through little dynamic UIs. There's a third thing, multi-step workflows. So if you have like user onboarding or like a checkout flow, where you have to go through multiple steps and you need the state from the first steps in the middle of it or at the end, it's trivial to do in React because all the state is there on the front end, and so you just have your components and you have your use state and it's all nice and pretty and it performs well and it's easy to write. It's a huge pain in vanilla Rails. It's an unbelievable pain because you have to, for every step of your workflow, you have to make a route for it, you have to make controllers for it, and then, let's see, what, yeah, okay, so this is the sort of fundamental problem. HTTP requests are stateless. Right, so when I have a web server and I get a request in, let's say in Rails, and I assemble my output, I go to the database, I get all this state, and I assemble the output and I send it back. When that person goes to step 2 of their workflow and they send another request to the server, everything I got for the first request, that's all gone, right? It's all been garbage collected. I have no idea where they are. And so to deal with multi-step workflows, you have to do a bunch of work. You have to make routes for every step of the workflow. You have to serialize and deserialize all of your client state. So if they fill in some form, I need to, even if I don't need all the information of the form a day from now, I only need it for the next 30 seconds while they complete the workflow, I have to serialize all that state and I have to persist it somewhere. I have to put it in the database, I have to put it in the cache, or God forbid I put it in the routes in the like query parameters. Like I don't know if you guys have ever seen like really complex e-commerce query parameters. That's serializing and deserializing state. They're just putting it in the parameters and in the routes. Yeah, so the server has no memory. You have to serialize and deserialize state on every request. Oh yeah, so this is the fun part. Right, so in Rails, doing this kind of thing is a huge pain, and it's so much of a pain that for most of these workflows, they just do it in JavaScript anyways. So they'll either just do it in vanilla JS, or at our company, we do it in React. You just ignore the whole problem, you just throw React on the page, you do it all in JavaScript, and then you have one nice API request at the very end, and you have all your information nice and tidy, and they've gone through their whole sort of workflow tree. Turbo does not help you with this problem. It doesn't do anything with this problem because Turbo has no client state. So you still have to serialize and deserialize everything, even if you're sending only over snippets of the page. You still have to know what they did, and then the server has to persist it between requests, which is, again, a huge pain. So then in the last 5 minutes, I didn't have time to make an example of this, but what if they weren't? And so who has heard of the Phoenix web framework? Yeah? Okay, so I think I have a little, did I add? Yeah, okay, so what is Phoenix and why is it cool? Phoenix is a hybrid of Rails and React. And so I made another one. What did you guys do here? And it's funny because this meme is actually really true because the original Phoenix developers were originally Rails developers, and they set out with intent to make a React-like web framework that kind of works like Rails. So it does React-style user state tracking to diff and render the DOM, but it does it all on the server, which, if we go back to HTTP requests being stateless, is kind of unbelievable, and it's a bit of a miracle. And the way it does this, yeah, okay, so yeah, this is only possible because with Erlang, the language that Phoenix is built on top of, they have this, I don't know, really sophisticated like process management system. And so in Phoenix, they built a web framework that does sort of user state DOM diffing. It does it all on the server, which means you have to track per user state, client state on the server. And it does this by creating a process for every user and then maps every inbound request to that process, which tracks state, pretty much the same way that React does it, via a sort of like use state-esque dynamic. And then whenever state that is coming in changes, the server knows for each user whenever their state changes, and it re-renders the DOM on the server and then sends back what is effectively an HTML snippet that gets swapped in and out of the DOM, but it's much, much more robust than Rails is doing it, Rails' version with Turbo, because it actually keeps track of every user's state, every user's client state, and it does it all in the server. And to my knowledge, I don't know if any other language can implement a framework like this because of their sort of per user process system. So again, we go back to this. Everybody's trying to just have one vertical line on top, and Phoenix kind of comes in. It's pretty good. So for static UIs, it works the same as Rails. It's basically just Rails in another language. And then the line kind of comes down like this. It's not all the way there with dynamic UIs, but it's pretty close. And the one thing that it kind of struggles with is the same network latency problem. So it's still sending HTML over the wire, and so you still have network latency whenever you click on stuff. They've done a bunch of stuff to minimize it. Everything's done over WebSockets. The DOM diffs aren't actually DOM diffs. They're like a much more minimal version of it. So they send a lot less information over the wire. They do it via WebSockets, so it is faster, but kind of no matter what you do, you still have the network there, and so your UIs will still have that delay on pretty much everything you do, to the point where even the Phoenix people still will use JavaScript frameworks to sort of paper over the network. And then, yeah, so this is the Phoenix people looking at everybody else. They have their one framework, it does everything, and they don't need to do any of this nonsense. I do have one more slide. Do I have, Roberto?
Yeah.
Do I have 2 minutes? Okay, so that's the talk. But has anyone heard of Seaside? Anybody? Okay, I went to a Ruby meetup and there was one guy who knew what Seaside was. Seaside is a web framework. It was a web framework made in Smalltalk. And these, I've never seen anybody, any framework more aggressively avoid the whole request response cycle with HTTP. Seaside came up with a sort of unbelievable solution to the same set of problems of not having state on the client. Their solution was kind of like Phoenix, but they don't have any per user processes that track user state. And they don't do the turbo style sending snippets over. This was all like 20 years ago. There's a feature in Smalltalk and in Ruby called continuations. And what you can do is in your application, you can use a continuation, and you can take a snapshot of the state of your entire application, and you can store it in a variable. You get a reference to it, and then later on in your code with that reference, you can reinstate the state of your whole application to where it was. You can sort of go back in time. And so what they did was every time a user, they would write out their code, and they would write it almost like desktop software, where they would just write out all their code, and then they would just like wait for user input. And when they did that, they would snap a continuation. They would store it in a giant hash with a UUID tag, and then they would send that. They would send the HTML response with that UUID tag, and then anything on the page that a user clicked on, the next request would have the UUID pointing to the continuation of where they were, and then whatever action they were taking on the page. And then when the server received a request, it would look up the continuation based on the UUID. It would reinstantiate the state of the entire application to where it was before, when they originally got the initial response. It would perform the next action, and then it would, so it reinstantiates the whole application, does one little action, again, waits for user input, sends the response back with a new UUID, it would snapshot a new continuation, and so the Smalltalk developers would just effectively write desktop code because they just didn't want to deal with any of it. The downside of doing this is that it's so memory consumptive that you could only have like 100 concurrent users doing anything in these applications. Development was really fast and it was really easy, and it was mostly used for like line of business software where you're only going to have 5 or 10 people doing anything at once within businesses, so like inventory systems and stuff like that. Yeah, that's it. Thank you.
We got time for some questions.
Oh, yeah.
So with where we're at today, are there any situations where you would choose Rails to build an app today?
Yeah, if it was e-commerce, if it was content, line of business software, anything where I feel like I'm not going to have a lot of dynamic UI or where the performance of the website doesn't matter that much, developing in Rails is really nice. It's really, really good. And with Turbo, if I go back to like this chart, with Turbo, like the middle of this, like right here, Turbo pushes the Rails line way up. It's really good. It falls off, again, for like really dynamic stuff, but that middle UI bit with Turbo, Rails is really good. It's really good. It's really good to develop in. It's really fast. Everything works really well. I like it a lot, but once you run into a wall. You do run into a wall. And this was actually the first time that I did anything in Next.js. Next.js is really nice. It's really nice with server components. I like React. You do all the dynamic UI and you still get, everything loads really quickly. That's pretty nice. That's pretty nice. Yeah.
I've not worked with Rails before, but I'm curious what the process looks like for when you have a Rails app and you want to have a React component on top of it.
Yeah.
Do you leave a sort of skeleton and then your JavaScript or React, whatever JavaScript you're
Yeah.
sort of insert something under the DOM, or do you actually try and hydrate a component?
There's no hydrating. You stub out a DOM element. The way we have it set up, on the initial page request, we will set up like initial data that gets attached to the DOM, I think via like data attributes, that will get pulled into React without having to do like a use effect fetch to go get it. But there's no server-side rendering and there's no hydration. It's just empty, and then it loads via these data attributes. And then the actual implementation of it, at the framework level, is a bit of a pain, and it took a while for us to get set up correctly, because like I said, it is a bit of a Frankenstein, where you're sort of stitching these two things together. Yeah. Anybody else? No? Yeah?
So you mentioned Phoenix.
Yeah.
Maybe you can clarify, is Phoenix like a different programming language, or if you are a Ruby person, you can jump on Phoenix without a hitch?
No, Phoenix is a web framework built on top of a language called Elixir.
Right, okay.
And Elixir is a language built on top of Erlang. And it was specifically a Ruby developer who wanted Erlang to look like Ruby, and then the Phoenix web framework was a Rails developer who wanted Rails in Erlang. And then the Turbo framework is inspired by Phoenix. So
But you have to learn a whole different.
it's a whole different language, and so much so I tried to set up an example, and I spent like 2 hours doing it with ChatGPT because I'd never written Elixir and I'd never written Phoenix. And I did all this stuff, and and I'm copying all these components and everything looks fantastic, and then I get to the very end and the whole thing doesn't compile, and so everybody's jobs are safe for, 6 months. So, yeah. Any other questions? Yeah?
You're talking about with the Rails with the HTML over the wire stuff.
Yeah.
It's closer to being able to handle more dynamic stuff.
Yeah.
Would the people in the Rails ecosystem, would they say is the pitch that it really does eliminate JS? Are they phrasing it that way, or are they like, no, it just should reduce the amount of JS you would ever need?
I mean, I don't know. DHH probably says that it does, but in general, no.
Okay.
People have a pretty good understanding that it makes that middle ground easier, but they know that they're going to run into a wall with it.
They would admit you would still.
They would admit, yeah, they would admit. DHH wouldn't, but everybody else, yeah, they know. Because there's no state on the client, so you're sort of making it up as you go. It's kind of like this, what's that word? What's the word for a fake store? I don't know. Huh? Yeah, it's kind of like a facade, not kabuki. I don't know. I'll think of it 30 seconds after I take this microphone off. Anybody else? Yeah?
You put in Astro, and it's island architecture.
No, and I don't know what that is. What is it?
So basically the idea is the way they try to solve it. One, they allow you to kind of bring whatever JavaScript framework you want.
Yeah.
The main thing they have is they try to get rid of the migration problem by allowing you to decide where you want your JavaScript to run.
Okay.
Which is kind of just what jQuery plugin thing was way back in the day.
Wait, where you want it to run, server client, or?
Yeah, so you render your whole page, but then you say I want this specific piece to have hydration and have interactivity
And they do,
The server
okay,
components with the use client directive.
okay,
Like, kind of be capable of that.
okay. I don't know, that sounds pretty cool. Yeah, but no, I don't know anything about Astra. Yeah. Anybody else? Yeah?
Just want to make a clarifying point. I know you have this site, that drawing that you have where you
Yeah.
have static UIs. Actually, React shipped with a method called set React to string method, something like that.
Wait, say it again?
React, at the very beginning of React, right, back in
Yeah.
even 2012,
Yeah, when it first came out or whatever.
they had a method called like React DOM dot set or set to string or renders a string.
Huh?
And so basically, the reason why we think that React is great for client side is because Create React app came out and made it SPAs very, very popular. It made it super easy to get up and running.
Okay.
What happened during that time was that there wasn't a Create React app for server static rendering, right? But React always had a method, render to string or render to whatever it was.
Yeah.
So you can always use React to create static web pages. It just took a lot of time to do it.
Okay.
Versus I can just use Create React app in 2 seconds and have
Wait,
it.
how did it work? What did the render? Oh, just, wait, so it would
Yeah.
render a component into just a straight string,
Yeah, on the server.
and then you would just load
And then
it?
just load it in the web page, right? So you have
Oh.
static rendering already.
My ignorance displayed for everybody. I had no idea. No, I didn't,
Yeah,
that's
mean,
cool. I had
So
no
like
idea.
Create React app kind of just.
Oh, it
made
sort of just
everything
made it, oh, okay.
SPA, SPA, and it's just
SPA,
reality.
okay. Because that's definitely like my perception is 100%, like SPA, dynamic interfaces, like complex stuff.
Right.
Where you change some state and you change 6 other things on the page is 100%.
And that's why Gatsby became popular because they're using render to string in the backend. All right,
Oh, they
created
were
a
doing that?
system.
Okay, they were doing that the whole time. Ah, okay.
Yeah.
Okay. That's pretty cool. I had no idea.
Clarify that.
Yeah. If there's no other questions, I do have one shameless sort of self-promotion bit. I'm looking for an engineer who works at Atlassian. If anybody is one or knows one, please come talk to me.
Cool.
Yeah. Well, my pleasure. Yeah. You what? Hey, I saw you do it last time, the TypeScript stuff. It was great.
So while our next talk speaker gets set up, I had a quick anecdote on TypeScript. Who's using TypeScript right now in their projects? Yeah. When you started using TypeScript, do you notice it takes you a little bit longer to create something? To create like an app, create the web page, right? When you use TypeScript, it just takes longer because you can think about types. Right, right. So quick anecdote, I hired a contractor a couple months ago. It took him 6 weeks to build out a certain component. And I couldn't figure out why it took him such a long time to do. And I looked at his GitHub code insights, and he kind of wrote like 600, 700 lines. And I was like, shit, 600 lines for 6 weeks. You know, it's not very good performance. And I was looking through his code base, and it was all TypeScript types everywhere. It was like pages and pages of just types everywhere. And the actual code that he was using to create this component was maybe 2 or 3, React components. And so I was kind of like, I don't know, being his boss, right? I was kind of pissed off about that. I was like, shit, man, paying so much money for this contractor who had 10 years of experience, a lot of money, and it took him such a long time to do something small. Fast forward 2 months later, I'm refactoring the code. It took me 2 hours to do. Why? Because he typed everything out for me, right? And I think that's like the power of TypeScript. It costs up front a little more time, but man, the refactoring that saved me to do, 6 weeks to 2 hours was just mind-bending. And so, lesson learned. TypeScript does work. It does what it's supposed to be doing. It is the religion of types, whatever, in our world. But it definitely changed my perspective on it. So with that, introduce Nathan. He's giving out our TypeScript guru. So let's hear him out.
Thank you. That's honestly a good segue into kind of my talk today. So I'll introduce myself, Nathan Drake. I think this is my third talk I've done here, all TypeScript based. I just love talking about TypeScript. I am a software engineer at Paylocity. I work on the design system, so we maintain the component library for the whole organization. Sidebar there, I'm sure some of you are looking for jobs. I'm not hiring, but if you find anything on our careers page, hit me up on LinkedIn. I can refer you. Happy to refer anybody. And please connect with me on LinkedIn. I won't remember your names. You don't need to remember mine, but we can connect on LinkedIn at least. Okay, so I'm going to talk about creating reusable components with TypeScript. And I don't mean, obviously all React components are reusable to a certain extent, but I'm talking about really like the design system kind of component library, atomic level components, like a button, an input, a button group or an input wrapper, those kinds of things. It's pretty easy to make just a button. I mean, we probably all did it at school or in boot camps, but it takes a couple of extra steps to make them type safe. So for our component library, we have like a legacy component library that we're deprecating that was built totally from scratch, and it is not type safe at all, and it's a huge problem. There are stupid little bugs that I get called into support for all the time that are really easy to prevent if you just take a couple of steps up front when you make your components. So that's what we're going to work on. So over here on the right, I have a pretty simple form. So for the sake of this, let's assume we're starting out an app, we're building our first form, and we know we're going to have a whole bunch more forms, and they're not all going to look like this. Or rather, we want them to look like this, but they're going to do different things. They're not all going to have 3 text inputs with name, email, password. There might be a select drop down, different things. So we want a good way to piece these together and not to style them repeatedly or copy paste their styles. Now, you may notice all of these verbose class names. I'm using Tailwind for that. Tailwind kind of lends itself to copy pasting styles, and that's totally fine to do. If I was making this form once, I wouldn't bother with abstracting all of it. But today we're going to abstract it because we're assuming we need to. And we're going to work on doing that with TypeScript. So for the setup here, I'm just in like a plain Vite app. And we have a form here, 3 inputs. And they're structured with like this kind of input wrapper div, a label, and then an input. And that's the first one. Here's the second one. Here's the third one. At the bottom, we have like a button row with 2 buttons. So we're going to start with the buttons down here. And by the way, if you have any questions along the way, feel free to interrupt me or holler if you can't see very well. Okay, so I have this components folder here under source, and we're just going to start by building or doing a button.tsx. So I'm just going to create a basic kind of button setup. Let's do just a plain button like that, and that is pretty much enough to do a button. I mean, we need to pass like children through, but like that is enough to just like render a button on a page without much effort. So let me go ahead and create a button props interface. I'm going to export it because I think it's a good pattern when you're making your components to go ahead and export your types. You may need them later, and then you don't have to worry about it. For now, we're just going to add in children. We'll do React node. And then we'll extract it from here. We'll have to add our type here. And then we just need to toss our children in the middle here. And now we should be ready to use it. So let me go over here and let me replace this. See if VS Code will import it for me. Yes, thank you. Okay, so now if I hit save, yeah. So now we can confirm we're using our component, and this is exactly what we were rendering before because we're not passing any attributes to it or anything like that. Now, quick sidebar here on just general React types. You've probably seen these 2 types before. React.React node, and then React or JSX element or React element, which are the same thing. If you are not sure what the difference is, the way to investigate that is to just kind of command click into it. Or on Mac, it's command click. On Windows, it's probably control click in VS Code. And then it'll take you into the React types package where you can see what's going on. So you can ignore this kind of inside joke down here. A React node is just anything you can pass to a React component that React can render. And that includes JSX, which is this one. But there's also just a string, a number, a Boolean, null or undefined or valid React children. And so that's why we accept that argument for our children, but not for our return type. Because we want our return type to be JSX. And if we click through here, we'll see eventually if we click through enough abstractions, eventually we'll get to, JSX element extends React element. They're the same thing. I don't know why we call them different things. And on that note, you've probably seen this just as JSX element before. The reason you add the React dot is this is deprecated. If you're in WebStorm, it'll tell you this already. You don't really need this return type here. Oh, this is just TypeScript being stupid. Another side note, if TypeScript's ever being weird in VS Code, just restart the TypeScript server before you debug something or pull out your hair. Reload Windows, the same thing. That's usually what I do. That saves a lot of headaches. So when you want to return type, use React.JSX element. I think you're future-proofing there. I think they're going to remove the JSX namespace, or rather just move it all onto the React namespace for some reason. You don't need this. Like if we were to remove it on our app here, you can see that it's inferred as the same thing. It's not necessary. Like if we return something else here, if I just return a string, I was actually kind of surprised this worked. I thought Vite would throw an error. It still renders just the word string, and you would know immediately if this was not working. The advice I've heard from Matt Pocock, who's my kind of TypeScript guru, is he says to put a return type on your functions when you're maintaining library code. The reason being, if somebody needs to extend your function, they'll have the type available and you can export it. Since we're making like these components to be kind of our component library, I'm going to go ahead and do this return type. The benefit is that it will be a subtle reminder to you to actually return the proper thing. So if I just had like some functional code at the top and I forgot to return anything, we're going to get an error to remind us, oh, you forgot to return something. Now, you would figure this out because your button wouldn't be rendering, but I like these little things about TypeScript. They can just save me a little bit of time moving forward. So, children is React node. Our return type is react.jsx.element. Okay, continuing on. On these two buttons, we have a submit button. So I probably want to put a type submit on there, both for accessibility and functionality. So let's do that. I add type submit, we get an error. This is probably not surprising. We haven't added it to our props yet. The only thing we added there is children. It's just saying that that type is not, or children and type is not assignable to the type we created. And by the way, this is what you normally see in a TypeScript error in VS Code. This is from an extension called Pretty TS Errors. Highly recommended. It makes it just a little bit easier to read very verbose errors. So how do we fix that? Well, old me, probably, or younger me, would have just done it like this. You just accept string as a type, add it to there, extract it from our props, and then we'll just pass it along. Now this is giving me an error because not any string can be passed the type. It can only be these three things. For the sake of argument now, I'm just going to throw the dreaded as any on there, and let's see what happens. So we pass type through, and let's inspect our submit button, and we have type submit on there. So this works. This works totally fine. we got the submit button on our submit button, and this works. But now let's go back and maybe I want to add an ID to this. So let's add an ID of submit button. Well, now you can see we have the same problem. ID is not on our types. And so this could go on and on because there are dozens and dozens of built-in attributes and props that come on a button element. So the way that my team handled it on our old library, that I was not a part of, I don't take credit for this, is other string any. And you may have seen this syntax like this, key string any. So this is just a variable name. This is the type of your key, and then this is the type of the value. And so this syntax allows you to pass anything you want into a TypeScript object. So it will enforce type and children, because we already defined those, but it will allow anything else. And so you can see, we go back here, ID is working fine. If we were to, what we can do is spread other at the end of here, and then we'll spread other into our component. And if I inspect that submit button again, we have our ID here correctly. So again, this code is working. What's the big deal? Well, this is how we maintain our components for a very long time, and I'll show you a couple of the issues. So one of them being we don't have any IntelliSense on this or autocomplete. So if I go in here and open my autocomplete menu, there's nothing there because type is just, we just typed it as a string. If I were to go into type on this input and open my autocomplete menu, I have all these values just pre-filled in for me. This comes from the React types library. And that's a pretty big, I would say, DX lift to have those. The other thing is if we misspell a prop, so if I add a class name here and misspell it, and let's just say we change the background color to something. See, I'm missing an E here, and we can go over to, I'm zoomed in really far. We actually, is this working? Sorry, no. So it's not working. We don't get an error in the development window. We get an error at runtime. And this error is just saying that React doesn't know what this is or what to do with it. So I believe it doesn't even pass it through. No, it does. So this is getting passed into the DOM. It's lowercasing it like an HTML attribute. And this is a problem because you may not see this in development. Hopefully you do. But we're not getting any indication here that this is a problem. And the users of our library will probably see this when they're developing, or they'll pass a prop onto it that they misspell. It might be a viable prop that's just misspelled, and they get this error, and it can be hard to find these. A lot of the support calls I have are working in component files that are 600 lines long, and finding one word that's misspelled is not very fun to do. So don't ever use the syntax if you can get away with it. So how can we make this better? Well, let's get rid of that. And let's throw, what we're going to do is we're going to extend this interface, from a type that comes from React or the React types library. So for a button, we're going to do React.button, HTML attributes. That requires a type argument, and it's I think it's HTML button element. Yeah, HTML button element. And this is going to give us all of those built-in props that come on a native button element. Ignore this error for now. We're going to investigate what these types are with our command click. So first I'll go to button HTML attributes. Now, 90% of elements you do this on are just going to be this HTML attributes interface, but elements that have unique attributes, like a button or an input or a label, like button has type and form and disable, and a div doesn't have those. So it has a specific interface called button HTML attributes. You don't need to remember this syntax, just know that it exists. Copilot gets this right 90% of the time. You can find it on ChatGPT. Of course, the best thing to do is to learn how to look into the React types library and find what you need to find. If we look at so these are the button attributes. These are the HTML attributes that all elements have. See here we have ID, tab index, a whole bunch of other stuff. That even extends to more. This one has all of our ARIA attributes, and then this one is where we get all the React event handlers from. I mean, all in all, I think there's actually that looks like well over 100 different props that we're just getting out of the box. So we certainly would not want to handle that manually. So in this error here, what this is saying is when you extend an interface, TypeScript merges those two interfaces. And they can't have conflicting values. So we can't have this string or this type string because it's not specific enough. It needs to be that submit or button or reset or whatever. Children this is the exact same type that's on there, so that's why it's not throwing an error. But we don't need to redefine it. That's kind of just a waste of time, so I'm going to delete that too. And we're still getting children as a React node, and we're still getting type, but this time it's more specific, and it's what we want. So let's get rid of this type any. And in fact, since we're not manipulating type, we can just get rid of that completely. And I'm going to rename other to props. Some people use REST here because you're spreading. It's not all of your props, and you can use REST. I just like props because I'm used to seeing that word. So we're extracting children. You don't have to because we're not manipulating it, but we might want to in the future, and so I kind of just prefer to do it this way. You can still just pass it through as a prop in that big object. Also, we don't have to alias this type. You can just use this directly and throw it here. I do that sometimes. But in the event of a reusable library, I am going to assume I may want to use this elsewhere to manipulate it, so that's just there for me, aliased. And then once I do want to add a custom prop, it's easy to do. It's just right there. I don't have to set up anything extra. And so this kind of pattern is like what I like to follow just for a basic component. And so now that we have that, if we go back over here, now we're getting an error for a misspelled prop. If I change that to be spelled correctly, we are now getting our pink button. And if I go to this type again and open my autocomplete menu, you can see I'm getting the options. So we're getting that type safety that we didn't have when we were using that other syntax. And if I open the autocomplete menu on the button in general, we can see all of those props we just looked at in the types library that we get type safety on and autocomplete. So now let's actually make this button useful. The whole point of abstracting this is, one, what we've done so far is we haven't added any value to this abstraction. We've just made sure this abstraction works as good as the native version. Because anytime you do an abstraction like this, if you're getting a worse version with less type safety and a poor developer experience, that abstraction is probably not worth doing. But here we're at least getting the same level of quality, and now it can be useful. So we're going to style this just so we have something to work from. I'm going to add a border white. Let's add a little bit of padding. And let's do a little bit of a rounded border. Okay, so that's starting to look like a button. Now, of course, you may have noticed the other button, still pink, and didn't get our border that we just added. Did anybody want to take a gander why? Did you see rewrite it?
I think last name.
Yeah, so it's class name. So it's because we're still passing class name. Here, I'm going to actually no. We're still passing class name through on the implementation of this button, but we're not pulling it out of the props. So when we spread the props, class name's still there. In fact, if we were to scroll through here, you would still see it there, but you wouldn't see children because we extracted it. And so because of the order here, we apply class name, then we apply props. It's applying class name, it's applying props with the other class name and then just deleting our class name. So whenever you use this syntax with the spread object, you need to make sure that you, oh, I did something stupid here. I'm zoomed in just a little too far. Okay, you need to make sure that you handle when you pull out a prop like this. So right now I'm just reordering it, so now it hits props first, then it hits our class name. Notice we're now getting our styles, but we're not getting the pink anymore. That's because class name gets applied here, our class name overrides it. So we need to merge that. I'm going to put this back at the end just because I prefer it. And this is where we want to make sure that we have the extendability of the components. So when you're making a component library, I think it's important to make sure that 90% of the time we probably just want it to look like this. But sometimes we're going to want it to be slightly different. And it'd be nice to not have to build a new component, just to be able to change it right there when we need it. So how can we make this merge? Now, we can just use well, first of all, if we just extract or destructure class name from props, you can see that now works because prop or class name is no longer in here. If we were to I guess we have 264 props on this. So if we were to be able to see that whole list, now class name wouldn't be on it. That's why it's not getting applied. And we just need to merge it with these. You can use a magic string, template literal syntax. We're going to use a function called CLSX. It's very popular for Tailwind usage, but for any kind of class name manipulation, it's pretty cool. Just import it like that. Now, if you were using Tailwind, you would probably want to add Tailwind merge here. Some people will tell you not to use that. It just merges the same types of class names together. But when you need it, you really need it, and then like 90% of the time you don't need it, and I think that's why people say it's not worth it. But ShadCN, which is like the fastest growing design library right now, or component library right now, is just using it on their function. He makes a CN function, utility function that you just export that wraps CLSX together with Tailwind merge. And if you're using Tailwind, just throw that on your functions and don't worry about it. But for now, all we want to do is have our classes where we're doing our styling, and then also accept the user's class name as well. And so you can see that works. So we have the border and we have that background color pink that we applied. And they just get merged in nicely and we're good to go. So now we have the type safety, we have a button, and we have the extendability because we can change the button anywhere we need to. And we actually do here. If I was building a design system, I would make button variants. I don't want my cancel button and my submit button to look the same. I probably want the submit button to be a primary button and the cancel button to either be a secondary or a destructive button. Secondary is probably fine. So I'm going to make this look a little bit different. Normally we'd make a variant. If you're interested in that, look at the ShadCN button source code. He does a great job with that. He uses a library called Class Variance Authority. And it's great for setting up variants, and it's also type safe, which is a huge bonus. But all we're going to do now is let's just do a background white and a text black. And so now that kind of looks like a primary button. And we have these nice reusable buttons here where they look the same, but we're able to like just slightly manipulate a one-off button without having to create an extra component. There's another one I wanted to do. We're going to wrap the on-click and add prevent default on there. Just because this is my app, and I hate it when buttons refresh the page. And if we were able to see the rest of this, anytime we hit the button, whether it's a submit one or not, it's refreshing the page, and it is adding this like parameter syntax here, or query params to our URL. So I think that's pretty annoying. We don't need that. We're in React. We have interactivity. So let's take out our on-click here, and let's do that here. So I will take our event in here, which is strongly typed. You can see right here, it's our mouse event button element. It's exactly what we want. And then we're just going to do e.prevent default. And now if that was all we did, if a user passed their on-click through, it would not work. So we need to do kind of a similar thing we did with the class name where we merged those. Like anytime we destructure a prop like this, we need to actually deal with the implementation of it. And so in this case, if it exists, we just want to execute it, and we need to execute it with the event passed through. And now we have prevent default on our buttons automatically, so we don't get that ugly refresh, and the on-clicks that we eventually implement for real in these buttons would get passed through and used. Okay, that's all we need to do for a button. The other components we do are going to be way simpler. Does anybody have any questions at this point? Yes?
What if this button has border line
Mm-hmm.
and we pass like a border of another color?
Uh-huh.
How can we show that it will be like
Yeah, so that's what that tailwind merge feature does. So if you were using plain CSS and the class name just applied all these different CSS properties, whatever hit last, the order would matter. Whatever hit last would get applied just like normal CSS. That doesn't work that way with Tailwind. These class names are hitting in order, but the style sheet, all that matters is what's on the style sheet, and that's a fixed order. So that Tailwind merge function sees it when there's two conflicting styles, and it tries to only apply the last one. And we can just look at it real quick. Tailwind merge. So it's a very small package, TW merge, and it has this. So like here, we're applying two different padding values, top, bottom, and then right, left. And then in our second class name, we're applying a padding 3 all around, which is padding 12 pixels. And normally, that may get kind of funky if we didn't use Tailwind merge, but with Tailwind merge, it would see this and only apply this one, and then get rid of these first two. For that shadcn function I mentioned, if you go to his installation setup, let's just do manual. Don't care about that. Oh, here we go. This cn helper function is what I was talking about. So you can just copy paste this, put it in your library, and so it Tailwind merge with CSX just combined, and then that would take care of that for you. So I'm not implementing here because we're not too worried about styling. But if I were creating these components for a app where I'm using Tailwind, I would make sure that I had that set up with Tailwind merge. And so we can see what happens if I pass a border to it without Tailwind merge. So let's do border pink, my favorite color today apparently. And it looks like it does get applied. So it worked there. But it gets especially funky when you're doing hovers. Like because I would do a different hover effect for this black button, and then I would do a slightly different color for the white button. And that would probably get pretty funky if we combine those. So just use Tailwind merge if you're making reusable components for your library. Okay, so let's do a couple others just to see how it works with simpler components. Oh wait, didn't you have one more question?
What is the reason you're going to use the functional component FC types with React?
Oh, good question. From what I understand, it is recommended not to use it. There's a couple of downsides to it, which actually that is helpful because I wanted to show how forward ref worked. So one of them is forward ref. It makes it weird with forward ref. The other is generics. So, okay, so let me show you what he's talking about. So the traditional way to type a functional component was to do it right here and do react.fc. So when you do it here, it's typing the entire component, not just the return value. When we were doing it down here after the arguments, we're only saying what the return value is. One, this just isn't necessary. You don't really need to say it's a functional component. It's enough to just infer that you're returning a JSX element. But if you were to take with a generic component where you're taking a type argument, which would be, I think, here, yeah, it gets super weird with JSX involved. So we take a type argument here, right, and we want to pass it through to something. Well, we're already past the function type, so it's kind of hard to pass it into the FC. It makes that weird, and there's a couple other reasons why. Matt Pocock has an article or a blog on his site where he talks about why. The short answer is you don't need to. The longer answer is there's a couple of downsides if you're doing some advanced TypeScript stuff. And it's also weird to me that it changes the color in VS Code. Not really sure which one I like better, but that bugs me. You had a question?
Up top, I'm just not as familiar with the type libraries React, but why is there the button HTML attribute with the HTML button element? Like, why wouldn't they bring
Yeah.
just one?
Yeah, that is interesting to me as well. So on the next components we do, it's a little more, it makes a little more sense. Like I would have thought that this could just be HTML attributes, and then the element you pass through pulls the correct extra types. But I don't think it works that way. And since it doesn't work that way, I do wonder why we need that. So like on a div element, we're going to do HTML attributes with HTML div element. And with most of them, that's all the syntax you need. With these input ones, you need those extra ones. Let's see if we can suss out. So you can see type argument here, getting passed through here, type argument here. So it looks like it's because of the DOM attributes. So let's see why. It is to strongly type the event objects passing through on the onClick. So where we use this is event object, so it passed that all the way down through the HTML button element, and then presumably pulled well, I guess the mouse event is coming from the onClick, but that element is pushed all the way through. And maybe we should check out why that is. Where is onClick? Oh my God, this file is huge. Okay, so here. There are so many abstractions in this library. You can learn a lot if you feel like taking the time to dive in. Yeah, the short answer is it has something to do with those event handlers, strongly typing those event handlers. Longer answer is somewhere in that React library. Okay, so I'll show that different syntax when we make one with a div. So I'm going to make a button row here. You could make just a layout row to do the same thing. All I'm doing is display flex, justify end, and a small gap. But when we make it, I'm going to want this flex wrap property on there. And that's because if I were to have a whole bunch of buttons in here, this would automatically spill over. Doesn't look great, but it looks a lot better than if we didn't have flex wrap there, where it just keeps going. So when we do it this way, at least we can have some responsiveness. Now, in general, I would probably say just don't put 6 buttons next to each other. That probably fixes it. But if you're making this for other developers, they're definitely going to do something stupid with it, so you got to be prepared. Okay, so let's make a button row. So same thing, just make a little component file like normal. We'll do button row. I'll go ahead and I know we're going to need children. I know we're going to need class name, and then we're going to spread our props. I'll grab the props in a minute. We'll do the JSX element thing. And this is probably where having Copilot would be helpful, but we just need a div. And in this case, I'm not even going to, actually, yes, I'm not even going to worry about extracting children because I know I'm not going to manipulate it here. We'll do class name. Let's do that for a second. And then spread our props. And then we'll define that interface that we were just talking about. So interface button row props extends. This time we're just doing HTML attributes straight away. We don't need the button. Still requires a type argument, and we're going to do div HTML div element, or maybe it's just HTML div element. So if you notice, if we were to change this to okay, what am I doing? Oh, there we go. I didn't return. See, that's where that return value helped me with my stupid syntax. So if we change this to button HTML attributes, that didn't do quite what I was hoping.
You're not using the type, so that's not.
Thank you. Sometimes it helps to code in front of people. Okay, that's still not flagging. I wanted to show why this would, where this would flag. Okay, there we go. So if we take the input HTML attributes and apply them to a button, we're going to get this error. It's a very verbose error, but it's basically saying you can't pass input props to button props. And if you go far enough down, it'll show a couple of specific ones. Oh, it's because they both have type, but they accept completely different values. And so this is where TypeScript will keep you in check that you're actually using the correct interface here. So that's what we need. Now this one you could do, actually just for the sake of showing you different patterns. Button row, we know we're probably not going to mess with that much. You could just throw the props in right here without abstracting them. And that's that. We will still need that CLSX function just in case we need to change things. And we'll copy our styles from over here. Whoops. Styles and then class name. Okay. So I need to import that. So this is the pattern for building like the simplest type-safe general component, where this is just a div with some styles on it. We're basically making a style component that's type-safe, that we can manipulate easy with Tailwind, and we can do anything we want with. So in this case, we're just passing the children through in the props. You can still extract that if you need to manipulate it. And we'll just replace this div with our button row. Don't know why TypeScript has not been, or VS Code has not been automatically importing those for me. Okay, so we have our button row, same styles. We wouldn't expect to see a difference. Just to make sure we have the right thing, let me increase the gap, and yep, that moves. So now we know we're using our button row. And so when you have it's pretty common in component libraries to use this type of pattern to make, if you use common flexbox configurations, like, okay, here's a flex column and I'm putting the same gap every time, you could just create a column component. I think React Aria has just like a flex component where you can, they use props to manipulate it. I prefer to just use the flex box straight away, but this saves a few steps if you're using this in a lot of places. Like with a button, if we're going to have multiple buttons in the same place, we can just use this over and over again. But we still get all of the autocomplete props that we want. So in this case, it's any valid React prop or HTML attribute you can put on a div is going to be right here. And let's do an input real quick, just to show that one because it's a little bit different. So I'll just go ahead and close these. Oh, actually, we'll just copy our button row to start from. It'll be pretty much the same. So let's create an input. And I'll copy this in, rename it input. And we just need to change our props. This time I will abstract it. We'll do interface input props, extends. In this case, it'll be input HTML attributes and then HTML input element. Again, you don't need to remember all of that syntax or words. Just look it up with an AI of your choice. And hopefully TypeScript will tell you if you've found the wrong one for some reason, or you'll figure it out. If we change this to an input and we use the wrong one here, let's just use the plain HTML attributes. If I import this here, yeah, so we can see it worked, but we're getting flagged on props that we know are valid. So we know that a name or input has a name attribute, but a div doesn't. And so we're getting this here, and that would be your clue that you've maybe pulled the wrong interface. If we correct that, the error goes away. And now we get that autocomplete back on our type prop. So we can have, we can select an email here, and we know that it's a valid value here. We'll do the same thing with these guys. Inputs. And now we can style it to match our button. So let's see, this has the classes from our button row. Let's just do a border. We're not going to see a border white. I'll forget that. Let's just do rounded, large, like our button, and then the same padding as our button. And now we have basically an input style component where we can throw this anywhere, have type safety, have a good input to start from with the same styles. So if I were finishing this out, I would go ahead and do the same thing with a label. I would probably make either, you could call it an input wrapper or an input field. Our designers call it a field question, like this wrapper on the input, but I think that's a weird name. And I would probably do the form. I don't like form components that have functionality in them. I like to use like React Hook form for that because that just gets convoluted. But I would still, like, we're basically using this form as a container, and it's going to have the same styles probably in the other places we use a form. So I probably would wrap it and style it just to have consistency there. Okay, any questions? Any other questions? Yes?
Can we please get back to the bottom row?
Yes.
If I get it right, we don't need to pass children, right, as a slot.
Yes.
But why don't we use the same approach for the bottom itself?
That would be like totally a preference thing. The point in doing that was to kind of show a different pattern. Whatever pattern you choose, I would just do the same thing. This like looks better to me to just have the children there, and if I ever needed to manipulate them in some way, I can't think of a good reason to do it on a button. Maybe if you were passing an icon in with text on a button and you wanted to look for the icon, but I don't like to do that kind of manipulation, so like I probably do lean more towards just like leaving it out, but that would be why. If you think that there are places where you're going to manipulate children, just know which pattern that you prefer. But you're right, we don't need to abstract children here and pass it through. If I delete that, it still works just fine, and we get the text through without needing that.
An example on that one is that if you're doing a busy button, like going to a loader, you can then swap out the children for a
Yes.
button.
Yeah, that's a great example. We do that exactly with our button. It's one of the only extra props we have. So I guess I can show that real quick. So that would be a custom prop. So if we just do a loading Boolean, and then pop that out here. And then if loading, we do a loader. If not, we do children. And what am I doing wrong? Oh, thank you. And then if we were to pass that to loading here, we should get, yeah. So that would be a reason, if you're doing stuff like that. Yes?
Is the event target type for your
Is the event target what?
on the is the event target already typed for you when you pass like those attributes in React? Or you have to type it because I remember I had an issue. I had to type the event target value all the time.
The event, oh, yeah. Yes, so I think that's what, this generic type argument is getting us, is the correct values on those. So if we go to our on-click here, well, I guess there wouldn't be a value on the event, right?
It's mostly for referring those.
Right, yeah, so if we were to pull that, we can check real quick. Well, let's do it on the abstracted version. Well, it wouldn't be on click, but it would be on change. Let's check out the event and then E dot, yeah. So you're getting all of those, you're getting the proper event with the proper values there. Is that what you were asking?
But there is like if you type in the value, event target value, then value is not the type of.
Oh, on the input?
Probably all the string though.
Yes. Type string has no call signatures. Is that just like that? Yeah, it would. That'd be where.
Probably in older versions of React.
Yeah, I mean, I would still use something like Zod or React Hook Form or Yep to validate my form. This is like, what we're trying to do here is get as good type inference as the native elements. And so if we achieve that, that's probably about as much as we can do for this step with TypeScript. And that was really our only goal for this. But yeah, so basically you get whatever the option was with the input. Now, I think number still gets rendered as a string. Yeah. So even if you change the input type to number, it still throws it out as a string. Yeah. Other questions?
Kind of a more broad question, but you said your job, like you or your team is maintaining component libraries used by your larger organization. We can talk about this after we round it, but just curious if there's any kind of, I don't know, insights of that role that you've, like, you probably talk to the users of your component library more than most component libraries maintain.
Yeah, probably so, yeah.
Curious if you've learned anything from that perspectives.
Yeah, so part of the, like we just started rebuilding like the next generation of our component library. We're using Adobe's React Aria, which is a headless component library similar to Radix, or MUI's base UI, I think is in beta, it's headless. React Aria has some pretty progressive like accessibility techniques. Seems pretty well respected for their accessibility, and it was what we could get the team to agree on using. But it seems like a really good option. So two of the main goals: one, components weren't type safe, so that's what I went over today. Two, components weren't flexible. So with our last iteration of the components, like I work at a company that's like, I don't know, we're like 6,000 or 7,000 people. There's like 300 products because it's a HR company. So we have like all these different features that we have to check, you know, when you're looking at our website versus ADP, we have to check all the same boxes they do. And our salespeople don't care what the things look like as long as they're there. So there's a lot of like half-baked features in ancient frameworks. And what happens is, we were just talking about this beforehand, a designer gets a task, and they just do whatever they want. And then the developer doesn't see the task until, Tuesday, and it's due Friday, and he's going to our component library and he sees, oh, this component doesn't do that, or that component doesn't even exist. And so they just have to roll their own thing. And then it doesn't even look as consistent, which you would think having a restrictive, opinionated component library would lead to a more consistent experience, but it doesn't, because a team of 7 people can't possibly understand the needs of 300 different teams, or 300 different products, I think like 50 different teams. So our approach with the next iteration is to make it more flexible. So the idea is like, if we give teams components like this, atomic components that are small and styled and flexible, and they can compose whatever they need to, hopefully we end up with a more consistent experience, because they're never going to need to roll their own components. So that's the goal. I'm interested to see how it goes. You'll have to ask me again in like 6 months. We'll see how it's working. But the tough part of that is, like, if we had 50 teams of like good React devs, I don't think it'd be a problem at all to use atomic components. Because like, it's like creating components like this, every React dev is just used to doing, aside from maybe the tail end aspect, which you can ignore. But we're used to, composing JSX elements together. But a lot of our teams there's a lot of like back-end C# devs that they're just trying to hack and slash a feature together. And they may not want to do this. They probably just want a form component passed to them where they just put in what they need and like, don't worry about it. So that'll be I think that's going to be our challenge, is just selling that to developers, that this may take you a second, a little bit longer to understand, maybe even a little bit longer to piece together, but you're going to be able to do everything you need to do without creating anything from scratch. Because I think that we're trying to like bend and not break, whereas the last one was just like, okay, it either works or you got to make your own thing. And if you make your own thing, we know you're not going to do it very well. So and then it's going to look, this app is just going to look like a different app for 20 years, and that's just the way it is. Yeah, it's a good question. Anything else? Or we got to be done? Yeah, we got to be done. Thank you.
Thank you, Nathan. Thank you, Nicholas. Yeah, stick around. We'll go downstairs right now. We don't have to put any chairs away or anything like that, so we can just pack up and head downstairs. And thanks again for coming out tonight. Oh, if you got tickets for down, yeah.
You applied in? I did leave, and then I came back. Just for like the...